Alright, so what I'm going to do is put a couple triangles here. Oops. Let's move this right here. And I'm going to copy that one. I'm going to paste it. So those two triangles are exactly the same. Alright, they're congruent to each other. They're exactly the same. But watch what I'm going to do. I'm going to change one around a little bit. I'm going to take this, and yeah, so I'm going to rotate it just a little bit. Oops, not like that. I'm trying to grab this middle thing. There it is. Stick that right there. Now this thing will rotate around that little spot right there. And let's just take this side right here. Now watch what I've done so far. They started off exactly the same, didn't they? Congruent to each other. That means that this side and this side were equal to each other, right? And this one were equal to each other, right? Okay, I didn't change the length. I just tilted it, right? You follow me on that? But in order to make this a triangle now, after moving this thing, in order to make a triangle, what am I going to have to do to this side right here? Not just rotate it, because if all I did was rotate it, it wouldn't. I'd have to extend it, right? I got to make it a little bit longer here, don't I? So looks about right there. So now, this side right here, is that equal to this side right here? No, it's not equal to it. In fact, watch what I'm going to do. I'm going to put 3 here, and I'm going to put 3 here, but I'm going to make it a little bit bigger. They don't do this in the book. I just did that because this one is smaller than this one. You with me on that? Or this one's bigger than this. Make sense? Now, these two are equal. These two right here are equal, and this one is smaller than this. Now, this is what we were talking about a little earlier. This comes into play. This is kind of what we were talking about before. If you have... Watch, if you have one pair of sides equal and you have 2 pair of sides equal, it's starting to look like that side thing, isn't it? Do you remember that? Okay, but what about the third side though? Are the third sides equal to each other? No, they're not. So we still call it side, but we call it the side inequality. All right, we call it inequality because they're not congruent triangles, are they? All right, we have 2 pairs of equal sides. But what's true about the third one? The third pair of sides are not equal to each other. So look, so these two right there are equal to each other. What about the third one though? That's not equal. Okay, so 2 pair of sides are equal to each other, but the third pair are not equal. Well, guess what? Remember what we just talked about as far as having one triangle and then the angle opposite the biggest side is the biggest angle? Well, what do you think might be true here? Compare angle A to angle D. Okay, they're not equal. That's right. Look at it. That's obviously not equal to that, is it? All right. But what can I say about angle A compared to angle D? If this side is smaller than this side, what do you think? This angle is going to be, let's go in order from A and D. Right. Angle A is going to be less than angle D. So watch. If, we might as well just put all the letters in here, right? Okay, so we've labeled it. So watch. If, we'll just say this. If BC is less than what? EF, right? Okay, so if BC is less than EF, then what can we say about the angles? Angle A must be what? Less than angle D. You see it? Because look, that's a smaller side than this. Look at the angle that's opposite that side. Everybody see that? Isaiah, you with me? So this angle right here is going to be smaller than the angle opposite the bigger side. I'll make that a big old arc just to show you the difference. You see that? So this angle is going to be smaller than this angle. Why? Because it's opposite the smaller side. You get it? So this angle is opposite the smaller side. It's going to be smaller than this angle. Why? Because this angle is opposite the what? The bigger side, right? Okay? The angle opposite the small side is going to be smaller than the angle opposite the big side. Or you could say it the other way. The angle opposite the big side is going to be what? Greater than, right? Bigger than or greater than the angle opposite the little side. Make sense? Now, that's only true if the other 2 pair of sides are equal to each other. You get it? So this and this have to be equal. This and this have to be equal. It's that third side that we changed. I changed the length of the third side. So if I change the length of the third side, the angle opposite the small side is going to be smaller than the angle opposite the big side. I think I made that pretty clear, didn't I? Any confusion on that? All right. So there you go. Let's do it again, but we're going to change it around just a little bit. Oh, by the way, they call this something different. Remember what we did with this? We kind of tilted it right at that point right there. I didn't change the length of it, did I? See? The length's not changing at all. I just moved it around. Moved it around kind of like a hinge. Do you see that? You know, like a hinge on a door, right? The door doesn't get bigger or smaller as it opens and closes, does it? No, it stays the same length. It just changes directions, doesn't it? Just changes angles. All right, so the book calls it the Hinge Theorem. I really don't like calling it the Hinge Theorem because it doesn't tell you really much about it. It does kind of explain that, okay, if we take this and we move it around, that side's got to be bigger. All right, it does say that, but I don't really like calling it that very much. My other books, I'll call it this, the side-side-side inequality. All right, so side-side-side inequality. If I have two sides equal to two sides and I have my other side, my third side, unequal, right? That means one's smaller than the other or one's bigger than the other. If I have two equal sides and one unequal side, then what can I say about the angles? The angles are unequal too, right? That means this one's going to be smaller than this one. That's called the side-side-side inequality, or they call it the Hinge Theorem. Make sense? All right. What they're going to do now is this. We're going to do the converse of it. So let's use the same triangle. Might as well. And I'm going to do pretty much the same thing to it, but the information that we've been given is going to be a little bit different. Okay? What were we given before? We were given that this side equals this side, right? We were given that this side equals this side, and then that's all right. Okay? Doesn't matter about the tick marks, all right? You see that's got one, that's got one. All right, this got two, this has got two. So those are equal. Now, before, what did I say? I said that this side was unequal to this side, didn't I? Yeah. All right. Well, this time what I'm going to do is talk about the angles. I'm not going to talk about the length of the side right now. I'll talk about the angle. Exactly right. All right, so that goes to there. So watch. I'm going to do the same exact thing to it. Look, I'm tilting it. Like, actually, let's do it like this. Let's just to be different, right? Let's make it real crazy. We'll go down like this. All right, you with me on that? I didn't change the length of it, did I? Okay, I kept, look, that stayed the same length as this. So let's put a one tick mark back on here. But watch what I did. What did I do? I changed from this big angle to what? A little tiny angle, okay? I didn't change this length of the side. I didn't change this side. But guess what's going to happen to this to make a triangle out of it? It's going to have to get small, about like that. Does it make sense? Okay? So look what I have now. It wasn't side-side-side inequality because I didn't know anything about these sides. What did I really change? I changed the angle. So what do you think this is? Side, angle, side, what? Inequality, right. Because they're not congruent to each other, right? These triangles are definitely not congruent. That means this angle is not equal to this angle. I'll put a little, no, I'll just put it like this. Okay, they are unequal. Look, but I do have two equal sides, don't I? I got this side and this side are equal. That's one pair. I got this side and this side are equal. That's a second pair. But the angle between those two equal sides are unequal, right? This one's bigger than this one. So let's do this again. Let's call it ABC. Let's call it DEF. We went different order, but who cares? All right. So watch. If angle B is greater than angle what? Angle D. What does that tell us about the opposite sides? Look.
They're unequal.
They're unequal. So that means what?
That means that line EF.
Let's do this one first. If we went B and then D, let's go this side. Line AC has got to be what? DEF. It's got to be greater than. That's right. It's got to be greater than EF. Javon.
Is the segment, is that supposed to be like flat?
Yeah, segments are straight lines.
No, the other one.
What?
Is that supposed to be like flat or something?
Flat?
Yeah.
I don't know what you mean.
Like the triangle.
I still don't know what you mean. What do you mean flat? I'm not sure what you're saying. I mean,
Not like
try to explain it better.
Not because it looks like from here, it looks like you're trying to like have the triangle like
flat
flat on the ground like this.
No.
Oh.
No, it's just squattier, shorter, right? But look, I didn't change the length of the side though, did I?
No, everything.
All right, and then you're right. I kept that length exactly the same. All I did was have it on a hinge, and I just moved it around. But I did change this side, didn't I?
Yep.
Actually, I looked at the angle. Okay, I changed this angle. So what happens to the side then? That got shorter, didn't it? All right. Now I could have rotated it this way, couldn't I? And then that third side would be bigger. Would you agree? But I already did that once, so I just figured I'll just be different and try it a different way. So that's the deal. So what do we say? AC must be greater than the angle or the side opposite the smaller angle. So this is the big side, and this is the what? The smaller side. You get it? All right. So what do I start off with? Two pairs of equal sides and an unequal angle in between them. What does that mean? That means the side opposite the big angle is bigger than what? The side opposite the little angle. You see the difference between the two? Because now I'm looking at the angles. I'm saying, okay, if I got a big angle here and a little angle here, the side opposite has got to be bigger than this. All right, enough of that. Let's do an example, and we should be good after we do the example. Okay, here's an example. This is what they give you, and they say compare WX to XY. All right? So when it says compare the two together, what does that mean you're going to do? You're going to say that WX is either what? Greater than or less than XY. You with me on that? I'm saying it right now in class, right? I did that with my other class. You know what one of the first questions one of the kids came up to me after they got the homework? They said, what does it mean when you say compare the two? Am I supposed to say how long it is and all that kind of stuff? I'm telling you right now, what does it mean to compare those two together? Just to show if they're either what? Greater than or less than. That's what I mean when it says to compare them. Everybody understand that? All right. So there should be no reason somebody comes up to me and says, what do you mean by comparing them? Because I'm telling you right now, it means either put less than or greater than. You got a 50-50 shot. But do you really want to rely on 50-50? No. You want to be 100%, don't you? Okay. So let's take a look. First of all, do we have the situation here? Do we have either side-side-side inequality or side-angle-side inequality? Side-angle-side. Where's the other side, though? I only have one pair. One in here. Good, good, good. XZ. Because of what reason? Do you remember? Reflexive. Do you remember that? Reflexive property? Okay. That's not that big of a deal, but it's good that you saw that. So look, I've got two pair of sides equal to each other, and I got my angle in between not equal. So 55, of course, is what to 51? It's bigger. It's greater than. So what does that mean? You look across 55, guess what's true about XY? It's got to be greater than what? WX. Or they put WX first. You would say WX is what? You would say less than XY. You get that? It's not so hard, is it? So you recognize that it's side-angle-side inequality, and then you look at the angles. You say, okay, which one, WX, is opposite the smaller one, so that has to be the small side, right? XY is opposite the bigger angle, so it has to be the larger side, right? So WX is less than XY. That's how you want to write your answer, just like that. Think you can handle that? It's not so hard, is it? Let's do one more, okay, and then I'll give you a worksheet to do. All right, here's your second example. This is exactly the stuff they give you. All right, they give you this picture. They tell you the lengths of these two sides. They tell you these two sides are equal to each other, and they want you to compare these two angles. Angle FCD and BFC. Now, when they say to compare them together, what does that mean to do? Tell whether they're what? Greater than or less than, okay? So tell me if FCD is either greater than or less than angle BFC, all right? Let's take a look and find those angles first. FCD, where is that? FCD, that's this one right here, okay? And BFC, let's find that one. BFC, that one's this one right here. Just because we'll put two arcs. And I got to decide which one's bigger, which one's smaller, Okay? Do you just look at it and say, that one looks a little bit bigger than that one? Is that what you do? Okay, doesn't work that way. Use the numbers. First of all, do we have side angle side or side 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 inequality? Side side side, right? Because look, there's two pair of equal sides. Where's my second pair of equal sides? The middle one, the what? Reflexive property, right? Okay, so look, I've got two pair of equal sides, and I've got a side that's unequal, don't I? All right. So look, which one's the bigger side? 3.6, right? So look opposite that side. That would be this angle right here. Okay. So this angle right here is what to this angle right here? It's greater than this one. But which order are we going to go in, though? We're talking FCD. So this one is what to this? That's right. It's less than angle BFC. Very good. Do you see that? So you just look to see which one is the bigger side. You look across from it, and that angle is across from the bigger side. So this has to be bigger than this. Or the other way around, this has to be what? Less than this one. Everybody see it? It makes sense, doesn't it? I think it does. Of course, I'm teaching it, so you'd think it would make sense to me. Are you okay with this? You sure? All right. All right, I think that covers it pretty good. All right, so 5-6. Remember, we're having a quiz tomorrow on 5-3. We'll do a practice test tomorrow. We'll review on Friday. We're going to review on Monday for the test on Tuesday. Remember that, okay? So test on Chapter 5 on Tuesday. Be ready for it. All right, that's it for today. I'll give you a worksheet.